McEndoo! Evening, everyone. So my name is Suzanne, and I am a physicist. I've been a physicist in one form or another for about a decade now, and there is one thing I have yet to figure out, and that is, how am I supposed to respond when someone goes, "Oh, physics, you must be so smart"? Now, I am pretty sure the answer is not yes. I do have that much cop on. But I think when people hear you do physics or that you have a PhD, they think you have this really inflated ego, and that's simply not the case. I mean, for me, doing a PhD was one of the most ego-deflating experiences of my entire life. When I was in my first year of secondary school, on Valentine's Day, I got a card from a secret admirer. Only time in my life. Thank you. And a couple of years later, a friend of mine confessed that it was him. He had sent me the card because when we started school, he had had a crush on me until, and this was how he put it, he got to know me better. Doing a PhD was more ego-deflating than that. And I think there's a couple of reasons. I think one of the big reasons is that by the time you finish your PhD, almost everyone you know has one. Or will do soon. So my two best friends have PhDs in computational physics and cryptography, so obviously we're a diverse bunch. And I know what you're thinking. You're thinking, Suzanne, get out of the university, get a hobby, meet new people. Excellent idea. So I thought, knitting. I'll join a knitting group. That'll be safe. Has a PhD, doing a PhD, doing a PhD on knitting. I think one of the few people in my life at this stage who doesn't have a PhD is my husband. And we've been together for 11 years at this stage, and he hasn't applied for a single PhD program. That right there is love. I think the other thing you have to factor in is that, okay, by definition, when you have a PhD in something, that means you're an expert in something. The thing you have to remember is that something we're experts in is a very small set of things. So take me for an example. I have a PhD in physics, so I am an expert in physics, right? So what I'm really an expert in is theoretical quantum physics. But what I'm really an expert in is the theoretical quantum physics of cold atoms, specifically bosons that are weakly interacting, forming a Bose-Einstein condensate that has vortices in it, but only in oval traps and not in round traps. And I would wager that I know more about this than all of you put together. But this guy knows more about plasmas than I do. You probably know more about the Higgs boson. So I mean, when I finished my PhD in Ireland, and then I moved over to Scotland, and I changed fields quite radically. So I went from the theoretical quantum physics of cold atoms in Bose-Einstein condensates with vortices, and I moved to the theoretical quantum physics of cold atoms in Bose-Einstein condensates with an extra atom. It was quite a learning curve. but I think I've got there. So I'm gonna try and explain some of my more recent research to you by form of an analogy, because we know those work so well for quantum physics. So my more recent research is kind of like being a quantum zookeeper. So kind of imagine I'm a zookeeper and I am cataloguing the animals. So I kind of go around, I get to the zebra paddock. Shape, horse-ish. Legs, 4. Colour. Now, for those of you who are not familiar with zebras, they have black and white stripes. But my form doesn't have an option for pattern. There's no stripes, there's no spots, nothing like that. So as a compromise, I guess I can go with just the colour, so a zebra's both black and white. But again, my form is very, very specific. I can only take one colour. So on a coin toss, I tick white and forget the black part, and I send this off to my boss, the head zookeeper, who looks at the form and goes, zebra, horse-ish, 4 legs, that would be consistent, white. A zebra is a white horse. Now the upshot of this particular bureaucratic gem is that my boss now has no idea what a zebra looks like. On the other hand, the zebra is fine. So this is what regular zoos operate like, in my understanding. So imagine this is instead a quantum zoo. So we're doing the same thing. I get to the zebra, shape, horse-ish, legs, 4, colour. And as we said before, the zebra is both black and white at the same time. And in quantum physics, we call this kind of state a superposition state. You may have heard of it before by one of the animals from our petting zoo, the Schrodinger's cat. In that case, the cat is both dead and alive at the same time. And we had to close that exhibit because it was frightening the kids. So we'll stick with the zebra. So the zebra is both black and white at the same time. Another thing we know about quantum mechanics is that when you observe something or measure it, you change it. So when I'm filling out my form, I am measuring the zebra. So if I measure and tick white, then the zebra becomes white, and it loses all of its blackness properties. Conversely, if I had picked black, it would become black and lose all of its whiteness properties. So essentially, I've just broken the zebra. And this can be really useful. Basically, quantum technologies are about the controlled breaking of zebras. But there's a slight problem. I can avoid measuring the zebra, but in the next field we have a camel. And the camel is minding its own business, and then it turns around, and there's a zebra. And the camel can also make an observation, so the camel has now observed my zebra and observed that a zebra is a black horse. So my zoo hasn't even opened yet, and I'm already down 1 exotic animal. Because no one's going to pay to see a black horse. There's a few ways you can go about trying to fix this. One of them is just basically isolate the zebra from everything and just send it into space. Now, it's not always practical to send a zebra into space. So we explore some other options. And one of the ones I was looking at is you take the zebra and you want to kind of surround it by a protective environment of other quantum animals. So other quantum animals would say the same black and white stripy quantum property. For example, white tigers. So you get your zebra and you put it in the middle of the field and you surround it with white tigers, and this is the safest place for your zebra, according to my mathematics. Now, in hindsight, it might have been better to try this with ring-tailed lemurs first. I'm not allowed in the zoo anymore. But the restraining order does say doctor. Thanks very much.